Hello, and welcome to this video on Windows Hyper-V support for MPIV and ODX on the next generation VNX platform. Here's the agenda. We will first go over what is MPIV. Then we will follow up with a short demo on how to configure your VMs with the MPIV feature. Once that is done, we will talk about the offload data transfer feature, follow up with a short demo as well. MPIV, or also known as M-Port ID virtualization, allows the mapping of multiple virtual worldwide port names to a single physical worldwide port name. With the new VNX series, MPIV support was added to Unisphere Host Agent on the Windows Server 2012. This enabled push registration from the VMs on a virtual port. Lastly, you must have MPIV-enabled environments such as MPIV-enabled OS, HBA, or fiber channeled switch. Here is an example of an MPIV environment. You will see that the physical server on the left has 3 VMs deployed. Each VM will have its own virtual worldwide port name associated with it. These virtual worldwide port names will be passed to the fiber channel switch, which then can be zoned to a unique storage port. Let's dive into the demo. We will first bring up the Hyper-V Manager. Once Hyper-V Manager loads, verify that your server is in the drop-down on the left. Next, we will create virtual SANs for our MPIV setup. Click the Virtual SAN Manager button on the right. Click Create to create a new virtual fiber channel SAN. Name the virtual fiber channel SAN MPIV SAN 0 and select the first HBA port. Next, click on New Fiber Channel SAN. Create a second virtual fiber channel SAN named MPIV SAN 1. Select the second HBA port and click Apply. Click OK when you are done. Next, we will add virtual fiber channel cards to the VM. For demonstration purposes, I have already created and installed Windows Server 2012 on a VM named MPIV VM. Right-click on the VM and select Settings. Select Fiber Channel Adapter and click Add. Next, select the virtual SAN named MPIV SAN 0. Click Add Hardware and select MPIV SAN 1 on the second virtual fiber channel card. Click Apply and OK when you are done. Next, let's power on the VM. Normally, after the VM is powered on, you will go to the fiber channel switch and configure zoning. For demonstration purposes, I have already configured the fiber channel switch. Let's now check in Unisphere to see that the VM has virtual port worldwide names logged into the array. Click on Hosts, then Initiators. You will see now that there are 4 HBAs that are logged in but not registered. Let's remote desktop into the VM and install the host agent. For demonstration purposes, I have sped up this portion of the video where we are installing the host agent. If we go back to the Unisphere Initiators tab, you will see that the 4 HBAs are now registered. Next, let's add some storage to this VM. For demonstration purposes, I have already created a storage group for the VM and a 300 GB LUN. Let's add this LUN to the VM. Click Add to Storage Group. Populate the Hyper-V VM storage group and hit OK. Confirm when the confirmation window comes up and hit OK. Now if we go back to MPIV VM, we will see that the 300 GB LUN is present. This concludes the MPIV demo. Now let's move on to the ODX feature. The next generation VNX now supports offload data transfer, or also known as ODX. This feature will offload copy operations to the array for pool LUNs. ODX copies will be at least 10% faster than traditional host copies. By using the ODX feature, you will save network bandwidth and host resources. Now let's move on to the demo. In our demo, we will be showing how Microsoft's System Center Virtual Machine Manager, or also known as SCVMM, takes advantage of the ODX feature. We will be showing that when we clone VMs, we do not utilize any CPU or memory resources on the Hyper-V server. For demonstration purposes, I've already created a VM on a Hyper-V server named Demo. Here in SCVMM, you can see the VM. To start the clone job, click on the VM and click Create and then click Clone. We are going to name the new VM Demo-ODX. Click Next to continue. Accept the default values on the screen and click Next. We will want to deploy the VM on a Hyper-V server. Select the second radio button and click Next. Here you can see that SCVMM has discovered our Hyper-V server. Select the Hyper-V server and click Next. Next, select a directory where to store the VM files. Our VM is currently deployed on the D drive, or also named ODX Demo. We will make a clone and put the VM files on drive E, or also named ODX Demo 2. Click Next when ready. Next, select the default values and click Create. Now you can see the clone job kicked off. Let's go to our Hyper-V server and verify no server resources are being used. When we go back to our Hyper-V server, we can see that CPU levels are very close to 0% utilization. Memory utilization is also very low as well. We can now see that the clone job done by SCVMM is taking advantage of the ODX feature. This concludes the ODX demo. For additional resources about these features, please visit the links below.